All right, welcome to this explainer, where we're going to do something, well, incredibly ambitious today. We are going to actively play the role of engineers, and our goal is to design a legitimate anti-gravity flying saucer. And the kicker? We're going to do it using current and near-future technology. Basically, we're taking concepts from physics, engineering, and a heavy dose of logic to assemble a blueprint for a vehicle that defies pretty much everything we thought we knew about flight.
So, let's just dive right into this by asking the ultimate what-if question. Can we actually build an anti-gravity flying saucer with today's technology? You might think, no way, but the surprising answer is yes. We really don't need magic, and we definitely don't need to break the laws of physics. We just need to assemble the exact right parts that either already exist today or are being actively developed as we speak.
But before we go conquering gravity, we kind of have to understand how our view of it has evolved over time. Let's look back to 1687. Isaac Newton basically told the world, hey, whatever's falling, gravity is the culprit. Fast forward to 1915, and Albert Einstein completely rewrites the rules by defining space as this giant, invisible bedsheet. You put a heavy mass on it, it creates a dent, and that dent is gravity. And if you ask modern physicists today, well, they'll tell you all about gravitons, these tiny hypothetical particles that are constantly being spat out by mass to create that pulling force. So the whole point here, the absolute crucial takeaway for our blueprint, is that we want to achieve the exact reverse of that pulling force. Anti-gravity is exactly what it sounds like. We need a force that aggressively pushes our ship up into the sky instead of pulling it down. To actually pull this off correctly, we've got to set some really strict engineering rules for let's call it our tin can. First, if it's going to be a true anti-gravity vehicle, it must be able to hover perfectly still in midair or space. Second, absolutely zero traditional engines or thrusters, none. Third, it has to be fully capable of deep space travel. And finally, of course, it must have that classic, iconic sci-fi saucer shape. I mean, we're not putting wings on this thing like a pigeon or an airplane. It has to be, unmistakably, a flying saucer.
So, tackling our very first hurdle here. If we outright refuse to add wings to our saucer, how on earth is this thing actually going to fly? Because let's be real, when most of us think of flight, we immediately picture airplane wings. But do we actually need them?
Turns out, not at all. Extensive wind tunnel tests have proven that a disc shape flies perfectly fine. You see, flight doesn't strictly require wings. What it really requires is a pressure difference in the air. As long as the pressure of the air flowing below the object is greater than the pressure of the air flowing above it, the object is going to experience lift. So, mathematically and aerodynamically speaking, our saucer shape, totally viable. Okay, but remember, we promised absolutely no standard engines. No jet fuel, no propellers. None of that. So how do we actually keep this incredibly heavy metal saucer just hovering in the air without one? To solve this, we're going to turn to a frankly mind-blowing material called a superconductor. It's a man-made material that, when cooled to a freezing negative 321 degrees Fahrenheit, shows literally zero electrical resistance. It basically becomes a totally open highway for electricity. But, and here is the absolute game changer for our flying saucer, a superconductor entirely repels magnetic field lines. It acts like a brick wall and absolutely refuses to let them pass through. So let's actually build our first levitation system. Imagine we lay down a track completely made of these superconductors right on the ground. Then we equip the bottom of our flying saucer with some incredibly powerful electromagnets. Because the superconductor track on the ground completely refuses to let the saucer's magnetic field pass through it, those magnetic field lines have nowhere to go but bend and push right back up. Because of this, the ship will literally hang in the air, completely locked in place by its very own repelling magnetic field.
And look, if you're sitting there wondering how on earth we're going to keep a track cooled to negative 321 degrees everywhere we go, don't worry about it. Scientists are actively researching and are incredibly close to cracking room temperature superconductors. This isn't some distant science fiction 50 years down the line. We're talking just a few years. And when it happens, it'll trigger the next major industrial revolution, totally solving our temperature problem in the process.
So, hovering brilliantly on a magnetic track on Earth? Check. But we want to go to space, right? How do we generate lift out there, where there are absolutely no superconductor roads to hover over? We obviously need a completely different way to lift off and fly out of the atmosphere.
And that brings us to our second incredible piece of tech, ion propulsion. Picture this. We install an atom ionizer all around the outer rim of our saucer. This device uses extremely high voltage current to essentially rip electrons away from the surrounding atoms, turning them into positive ions. Here's the step-by-step hack that actually makes this work. Once our high voltage turns those surrounding atoms into positive ions, they are violently attracted to a negatively charged foil that we've positioned right below them on the ship. These positive ions rush downward toward that negative foil at just incredible speeds. And this massive, rapid downward rush of atoms, it generates an unbelievably strong upward thrust, physically pushing our saucer up into the sky.
Now, this brilliantly illustrates a huge misconception. You're probably thinking, wait a second, space is a vacuum. There's no air. This literally won't work. Well, time for a quick fact check. Space is absolutely not empty. Research proves that interstellar space contains high to low density atoms scattered everywhere. We don't need breathable oxygen for ion propulsion, we just need atoms. And outer space has more than enough of them to fuel our ion lift all the way to the stars. Okay, so we've got our upward lift perfectly sorted. But just bouncing straight up and down isn't exactly a space journey, is it? We have to be able to steer this vehicle forward and backward. And remember our golden rule, absolutely no traditional thrusters allowed. So how in the world do we move horizontally? Enter the magnetic monopole. Normally, every single magnet you've ever played with has two poles, a north and a south. If you put a regular magnet in Earth's magnetic field, both poles pull in opposite directions, they cancel each other out, and the magnet just sits there. But an MIT cosmology professor named Ruth actually mathematically proved the existence of magnetic monopoles. These are magnets possessing only one single pole. By slapping these single pole magnets onto our saucer, we unlock some seriously incredible navigation. Think about it. If we activate a north monopole, the ship is going to be aggressively pulled toward Earth's geographic north pole. If we activate a south monopole, it flies south. By using artificial intelligence to rapidly switch back and forth between the north and south poles, our saucer is going to be pulled in a blazing fast, controlled zigzag pattern across Earth's, or honestly any planet's, magnetic field. Add a simple rudder, and steering is a breeze. All right, so we've got the mechanics figured out, right? We have superconductor hovering, we have ion propulsion for that massive upward lift, and we've got magnetic monopoles for steering. But let's be practical for a second. What could possibly generate the sheer massive amount of electricity needed to power atom ionizers and rapidly switching monopoles all at once? Well, the answer actually already exists deep in our oceans. Just like a modern military submarine, we are going to drop a miniature nuclear reactor right into the heart of our flying saucer. Whether it ends up being fission or eventually fusion, a compact reactor can easily fit inside our ship, and it'll provide virtually endless, massive electrical juice to run the entire anti-gravity system. You know, throughout this whole explainer, we've basically been acting as engineers, taking different pieces of cool technology and assembling them to solve a really complex problem. And this actually brings up a fantastic question that gets asked all the time. What exactly is the difference between an engineer and a scientist? The divide actually looks something like this. Engineers are basically the ultimate problem solvers. They take existing technology, resources, and all the known rules, and they assemble them to build active solutions for real-world problems. That's exactly what we did today with our saucer blueprint. Scientists, on the other hand, well, they're the ones generating the brand new ideas, working out the complex mathematical equations, and running experiments to discover the total unknown in the first place. And actually, even within science itself, there's this really fascinating split. You have your theoretical scientists, think Albert Einstein, who rely on pure math and literally just a piece of paper to prove massive universe-altering concepts like E equals mc squared. But then you have experimental scientists like Galileo, Marie Curie, and Rutherford. When they had these wild, groundbreaking ideas, they went out and physically invented and built new tools to actually test those theories out in the real world. So today, we basically acted as both, theoretically piecing together an anti-gravity saucer using room temperature superconductors, ion propulsion, and magnetic monopoles. But as we wrap up, I want to leave you with this final provocative thought. Looking at the unbelievable blueprint we just created together, which of these incredible technologies do you think is actually going to define our real-world future? And which one do you think is just a scientific waste of time? Keep exploring, keep questioning everything, and I will see you